Ladies and gentlemen, welcome to Unit 6 of our Accuplacer prep course. We're going to be looking at word problems. So what we're going to be doing is we're going to be looking at these word problems for keywords and how we can write expressions or basically model these problems. We're going to talk about defining our variables very well, and we are going to go over some test-taking strategies on how we can eliminate some answers immediately to help us guess, even if we need to, although we want to try to avoid guessing. But really narrow things down, really look at the details, because a lot of the wrong answers that appear in these problems are actually numbers that will show up elsewhere in your work. So you got to be very, very attentive to what they're asking for. Okay, so our first question here is Frank. He's out buying a TV. So he pays 5% sales tax on his television, which cost $769 before taxes. What did the television cost in total? So a couple of things that really stick out to me are that we are looking for the total cost. Okay, so I'm not solving for how much tax did he pay. I'm not looking for his price before taxes. I want in total. So after he buys the TV and pays the 5% tax, what's the total? The other thing that's very important is obviously how much tax he's paying and the price before taxes. Okay, so what should make sense is that his total cost should be more than his cost before taxes, because he has the price before taxes, then he pays the tax, and then that gives you your total cost. So if we look at our answer choices, B makes no sense because it is far too small. I would bet that that is the 5% sales tax that he is paying. Okay? So if you calculate the 5% sales tax, you see that number, you freak out because you see that number on the answer key and you pick it. But you're wrong, because we're not looking for that. We're looking for the price in total, which means the answer must be larger than 769. So D is also wrong. So that's smaller for some reason. E is larger. However, it's only 45 cents larger. And if you've ever gone to any store anywhere and bought anything, that seems like far too little tax. Okay? So really, after doing no work, we are left with A or C. So now let's actually do the work. I have 5% sales tax, which is basically multiplying by the number 0.05. Okay? Because a percentage is really a fraction of percent, which is 5 per 100. So you're paying $5 in tax on every $100 of merchandise. So the taxes that I am paying is 0.05 times 769. Okay? So a percentage question like this would definitely be a calculator question. So 0.05 times 769 will give me a total of 38.45. Okay? Which is kind of what we guessed before, looking at B, that is the amount of tax that we're paying. So we are paying the $769 plus $38.45 in taxes, and that gives us a total of $807.45. Okay? So it looks like our answer should be C. Another way to get to that is, instead of multiplying by 0.05, is you take 769 and multiply it by 1.05. Okay? And what the 1 does is the 1 represents as a fraction 100%, because you're paying 100% of the price, the original price, plus the 5% of sales tax. So you can kind of cut out the middleman and multiply by 1.05 when you're calculating 5% sales tax. Okay, so this one, I'm assuming this one might be a non-calculator question, so let's approach it as such. A movie theater sold 422 tickets on Friday. On Saturday, they sold 518 tickets. What is the approximate percentage that ticket sales increased on Saturday? Okay, so let's look at a couple of things that, let's do some quick percentages just to see what's going on. So if I started with 422, we'll look at this a couple different ways. and I went up 100%. Okay? A 100% increase is doubling. So that would bring me to 844 people. Okay? If I had only a 50% increase, then I'm increasing it by half, which would be 211. So that would bring me up to 422 plus 211 would be 633. Okay? So, what we actually went to from 422 is we actually ended up at 518, which, as you can see, is clearly less than 100, less than 50. So this answer of over 122%, that seems ridiculously high. 123%, ridiculous, way too high. If we increased by 100%, that'd be 844, that's too high. So really, we're already looking at either 42% or 23%, okay? So now, if we're going to do this without a calculator, there's another couple ways to look at it, which is to go from 422 to 518 is approximately 100 more tickets. And so if I'm increasing it by 100, this is about 400, rounding down quite a bit. But to go from 400 to increase it by 100 is what percentage? So what percentage is 100 out of 400? And that is 1/4, which is 25%, or 0.25. So it is approximately 25% of an increase, which A is where we want to be. So it brings us to 23%. If this were a calculator question, which I'm assuming it would not be, what you would do, or perhaps it would be, what you would do is you would say, well, if I started here and ended up at 518, I would say, hey, what is 518 divided by 422? And I'm going to get a decimal for that. And the decimal that I get is 1.227, and then with some more. So that means that 518 is 123% of 422, which is very tempting for you to select C. However, just because Saturday's sales were 123% of Friday's sales does not mean it went up 123%, because 100% of Friday's sales is the 422. So it actually only went up from 100%, the 23. Okay? So 123% increase would be more than doubling. And this is only a 23% increase from Friday. Alright, so this is a kind of a very classic percentage problem. Although they kind of throw a monkey wrench in there in that it's really almost two questions in one. So here's some verbiage for you. Is that the word is means equal sign. I've probably, in all the years that I've been taking math, and in probably the 6 or so years that I've been tutoring and teaching math, I don't think I've ever found any other way of hiding the word equals. Or at least if I haven't been able to find another way of hiding the word equals, I've never found another meaning of the word is in a math statement. Is means equals. So that means 8 is 40%. 40% as a decimal is 0.4 or 0.40 of a number. Do you know what that number is? I don't know what that number is. That is a variable. So 8 is 40% of a number directly translates to 8 is 40% of a number. So 40% of a number. And it reads exactly like that. 8 is 40% of something that I don't know. And you could write a statement like that immediately. Okay? So this would be a calculator question. If I'm going to solve for x, I want to get rid of the 0.4, so I'm going to divide by 0.4 on both sides. So we have 8 divided by 0.4 gives me 20. So I have 20 is x, which is nice. 20 is right here. So I would hastily click that answer, and I would be wrong because you got to read the whole question. Is the question, what is the number? No. The question is, what is 15% of the same number? So what is 15% of 20? Or what is 15% of 20? What is 20 times 0.15? So remember, 15% is the decimal 0.15. So 15% of 20 is 3. And so we're going to want the answer of 3. Okay. Ways that we could have reduced this at the very beginning is 8 was 40% of the number. So 15% of the number would have to be less than 8. Does that make sense? Because if 8 is 40% of something, then 15% of something is even smaller than that. It'd have to be less than half of that. So it'd be 40% is more than double 15%. So it couldn't be 20, and it couldn't be 15. And it would and since 15% is less than half of 40%, it actually couldn't end up being 6 either. So you're really just kind of then looking at between B and C at that point. All right, so this is a great kind of a piecewise function. And what a piecewise function is a function that covers or that follows different rules under different circumstances. And I'll show you what I mean by that in a second. So Grace worked from 7 a.m. to 6:30 p.m. She gets paid $13 per hour and time and a half for an hour is over 8 hours. How much did she get paid? If I'm going to be totally honest with you, I don't know a way to eliminate any of these answers right away. So in all these examples beforehand, I've had ways for you to kind of look at answers that made sense or answers that don't make sense. Without doing any work, the numbers ranging from $152 to $193 are actually like close enough where I would have no idea how to reduce this. So we've basically just got to do the whole work from scratch and just see that we get the right answer. So if I'm working on this, first question is obviously how far do you have to, or how long is she working? So from 7 a.m. to 6:30 p.m., how long is that? Okay? And going from a.m. to p.m., you kind of want to always kind of look at noon as being your barrier. Not noun. Noon. So from 7 a.m. to noon, that's 7 to 8 to 9 to 10 to 11 to 12. So from 7 to noon is 5 hours. So it's like 5 hours before noon. And then from noon to 6:30 is 6.5 hours afterwards. So going from AM to PM, it's kind of good to break it up from time before noon, time after noon. So she works a total of 11.5 hours. Okay? And I'm just going to represent that with a giant line. So this is when she starts working, back here, at time equals 0. And then when she stops working, at the very end, at time equals 11.5 hours. So she worked a nice long day. Now I want to break this up in how much she's getting paid. Okay? So at some point over here, it breaks off. Because in these 8 hours, she is getting paid her $13 an hour. Okay? That's her rate. And then after 8 hours, which now from 8 to 11.5, 8, 9, 10, 11, that's 3.5 hours. She's making time and a half, which means she's making $13 and she's making time and a half. So 13 times 1.5 is 19.5. So $19.50 an hour. Not bad. So her rate for these last 3.5 hours is $19.50 an hour. Okay? And then I want totals. So how much money does she make working for 8 hours at $13 an hour? And that comes to $104. And then how much does she make in overtime pay, which is working 3.5 hours at $19.50 per hour. So that is 3.5 times 19.5 And you would have a calculator for this. And this is $68.25. So she makes $104 in kind of standard pay, and then $68.25 in overtime pay, and those add to $172.25. Which, cross our fingers, is on the list? $172.25 certainly is. It is E, and that's our answer. Okay, so looking through the questions that we're going over, I think this one is very, very much probably the most difficult one. I think it's very, very difficult because it's very hard to kind of understand what's going on. So 100 pens cost X dollars. How many pens can be purchased for 50 cents assuming the same rate? And that seems incredibly difficult. This is a case where if I were told that I wasn't allowed to use a ratio, it would take me much longer and I'd have a very hard time with this problem. However, with ratios, we can handle this pretty easily. And so what I mean is that because we're assuming the same rate, that means that the cost is always the same. So the ratio of how much you pay for how many pens you're getting never changes. Okay, so there's no like discounts for buying in bulk, is basically what that means. So I can set up a ratio of either pens to dollars or dollars to pens. It doesn't matter how you set it up. So pens to dollars is my ratio. That means that I can set up a fraction of 100 pens is sold for X dollars. Okay? So I have 100 pens to X dollars. And because the rate is the same, then that means that that ratio, that price, will be the same for, I don't know how many pens. I'm going to put a question mark. Some number of pens for 50 cents, which is $0.50 of a dollar, so $0.5. Okay? And maybe just for the algebra, just so I don't try to confuse you, maybe I won't use a question mark. I will use a T for like total. Okay? So it's going to be the total number of pens that we could buy for 50 cents. And so now what I've created is I've created two equivalent ratios, two equal fractions. And a good thing you can do when you have two equal fractions, you can cross multiply, which means I can multiply across these diagonals. So I can get 100 times 0.5, or 1/2 of 100 is 50, and that's equal to my total times x. And so to get my total, I just divide by x, and I get my total is equal to 50 over x, which means that I can buy 50 over x pens for 50 cents. Okay? Which, in the context of the problem, I'm not sure if you would understand what that means in the context of the problem. I don't know if I understand what that means in the context of the problem, as far as how many pens we're actually talking about, but it doesn't matter, because we've been able to come up with an expression that works, it shows up in our list, and we know that it's correct because we've set it up following a ratio of our choosing. So again, I think it's a very abstract kind of question, but if you set up ratios when things are the same, so things are going to always have the same price per pen, you can still get to the right answer without really fully understanding what 50 over x really means in this problem. Okay, so this last one here is actually not a multiple choice question that I found. It's kind of a, I really wanted to go over a couple of, how to write an expression for a coin problem, because all the practice exams that I've seen have questions like this on them. They love them, especially because it forces you to use some things that you know that they're not going to tell you. Mainly that like a penny is worth $0.01, a nickel is worth $0.05, a quarter is worth $0.25, etc. So here we're using two variables. We're using the letter D and the letter Q. So D is our number of dimes, and Q is our number of quarters. And we want to write an expression for, if I have D dimes and Q quarters, how many coins do you have? So this seems almost too easy, because if you have D dimes and Q quarters, then you have D plus Q dimes and quarters. So if I have 3 of one and 5 of the other, then I have 8 coins. Like, that's very straightforward. You're just adding them. However, there will be several times where you'll be forced to differentiate between a question like that and number 2, which is you have D dimes and Q quarters. Write an expression for how many dollars you have. So now I'm not just adding them, because dimes and quarters aren't worth the same amount of money. They're worth the same amount of, like, coin, if you want to put it that way. Like, they're each 1 coin. Like, one's not more of a coin than the other. But for question number 2, they're not equivalent. They're not worth the same amount of money. So if I had D dimes, how much money is worth there? So a dime is $0.10. A quarter is worth $0.25. So if I had D dimes, that means for every dime I get 10 cents. That's 0.10 D. So it means if I had 15 dimes, I'd have $1.50. And that would be plus, and I have 25 cents for each quarter. So that would be 0.25 Q. So if I had 4 quarters, that'd be 4 times 0.25, that'd be $1. Okay? And that's how I'd write that expression. So you have to be very careful in how you are reading the question, in whether you need to include the price or not include the price when you're writing an expression like that. Okay? And there is a question like this on the practice that I've created for you guys to work on. So keep this in mind when you go there to follow your notes. Best of luck on those, and good luck on the post-test.